Hello everyone to AMIG registration lecture. In this lecture, we will introduce the classical registration problems. According to it, there is a system between the original AMIG and the acquired AMIG registration, which introduce some type of the degradation. The system can represent the Hubble Space Telescope or the turbulent atmosphere, or be combination of the motion of the object in the scene and the motion of the camera. We will degradation system is a linear and spatially invariant. The both and the modeling of the degradation and erase removal are relatively speaking and simplified problems. We show the mathematical models for the systems, introducing some of the common encountered LSI degradations. Of lecture, there is almost always the ever-present noise in the data as part of the degradations. We show how is severity of the noise typically measured in AMIG registration, as well as objective metric used for the estimating the involvement in their storing AMIG when a scientific experiment is conducted. Let's start it. In this lecture, we will talk about the introduction of AMIG registration and introduction about the AMIG processing, and we will talk about the mini knowledge in AMIG registration and AMIG processing. And in the second section, we will talk about the AMIG registration or what is AMIG registration and the basics of AMIG registration. And in the third section, we will talk about the degradation model or degradation models. And after that, we will talk about the noise and AMIGs or noises and AMIGs and the techniques, noises, techniques, and the AMIGs. In the fifth section or in the last, we will talk about the noise models. How many noise models or noise techniques. Let's start it. An introduction. Hello everyone, I'm Tamim Hizam. I'm a graduate student at Computer Science and Engineering in the University of Science and Technology. This lecture is a student activity from Liang Xiao professor. What is the AMIG registration? AMIG registration is the operation of taking a corrupt noisy AMIG and estimating the clean or original AMIG. Corruption may come in many forms such as motion, blur, or noise and camera misfocus. AMIG registration is performed by reversing the process that blurred the AMIG and such as performed by imaging a point source and use the point source AMIG, which is called the point spread function, BSF function, to restore the AMIG information lost to the blurring process. AMIG registration attempts to restore AMIGs that have been degraded. We have two or for AMX. In the first AMX, this is before the operation, and this after the operation. This is had a high quality, and it is clean. Yeah, and this is a original AMIC, and this is before the operation. This non-original AMIC. This is after the operation, and this is after the operation, and this is before the operation. Degradation model. We have this diagram of general degradation model. We have X and Y, and we have operation, and we have the adding noise. X is the original AMIC, and Y is the corrupt AMIC or the corrupted AMIC, where Y is the corrupted AMIC obtained by passing the original AMIC X through a low pass filter. This is operation is low pass filter or blurring function H, and adding the noise to it, to the corrupted AMIC. We get Y. Y is the corrupted AMIC. Noise and AMICs. The sources of noise and digital AMICs arise during AMIC acquisition or digitization and transmission. And imaging sensors can be affected by ambient conditions, and after that interference can be added to an AMIC during transmission. And we have 5 AMICs. The first AMIC is original AMIC, and the second AMIC is the optional blur, and the third AMIC is motion blur, and this is AMIC also this is AMIC is special quantization or described pixels, and this is additive intensity noise. Look the difference. We have a lot of difference between those AMICs. This is original AMIC. Noise model. We can consider a noisy AMIC to be modeled as the follows. We have this operation. This operation is G of X and Y equal F of X and Y plus N of X and Y. This operation where F X and Y, this is the original AMIC pixel, and N of X and Y is the noise term, and G of X and Y is the resulting noise or resulting noisy pixel. If we can estimate the model of the noise in an AMIC, This will help us to figure out how to restore the image. Again, we can consider a noisy image to be modeled as this operation. Where f of x and y is the original image pixel, and n of x y is a noisy term, and g of x y is the resulting noisy pixel. If we can estimate the model of the noise in an image, this will help us to figure out how to restore the image. Filtering to remove noise. We can use the special filters or different cans to remove different kinds of noise, and the arithmetic mean filter is a very simple one, and calculated as this operation. This is operation we can get the arithmetic mean filter, and this is implemented the symbol something filter blurs the image to remove noise. Noise models. There are many noise models, or many different models for the image noise term x and nx, y. This is the first one, or the first noise model is salt and pepper noise, and the second one, or the second noise model, is Gaussian noise and speckle noise, and the fourth noise model is exponential noise, and finally we have uniform noise, salt and pepper noise. This is the first one of the noises, is salt and pepper noise. It's known as shoot noise or impulse noise, and its appearance is randomly scattered white or black, or both pixels over the image, and there are only two possible values exact, that is A and P, and the probability of each is less than 0.2. And we have two image. This is the first image is original image, and the second image is image with the noise, or the with salt and pepper noise. Filtering techniques. In this noise, or in salt and pepper noise model, there are many filtering techniques in it. The first technique, or the first filtering technique, is mean filtering, and the second one is median filtering. The third is Gaussian filtering. There are three filtering techniques in salt and pepper noise. Gaussian noise. This is the second one of the noises models. Gaussian noise is caused by random fluctuations in the signal. It is modeled by random values and added to an image. We have example about, for example, about the Gaussian noise. This is without Gaussian noise, and this is with Gaussian noise. And Gaussian noise, there are many filtering techniques in Gaussian noise model. The first filtering is, or the first filtering technique in Gaussian noise is mean filtering. The second one is median filtering and Gaussian filtering in Gaussian noise model. Finally, we have uniform noise. This is the last noise in noises models, or the noise models. The uniform noise caused by quantizing the pixel of image to number of distinct levels is known as quantization noise. And uniform noise can be analytically described by this is syntax. This is syntax define the uniform noise, or we can describe the uniform noise by this is operation, or this is syntax. And we have an example about the uniform noise. This is without uniform noise, and this is with uniform noise. Look what the difference between two images. Okay, this is our lecture, which was about image registration. Thank you for your listening.